Okay, so she should be recording now. I can edit any start bit out, as I always do. So I've got a couple of questions here from this particular topic that I've just picked at random to go through. The first one's a trig one, so let's have a look at that. I should have got my pen in my hand before I started, shouldn't I? I'll edit that out. All right. So the question was, just move this guy down the bottom. The question was, if we have the function, whoops, let's get a pen up. Let's go blue, or purple, blue, blue's fine. If we have y equals cos x, and we want to know the equation of the tangent at pi on 6. So what is the equation of the tangent when x equals pi on 6? Okay? So the first thing we need to do is work out what the corresponding y-coordinate is. Remember, in order to work out the equation of a tangent, we need a slope and we need an x and a y value for a point. Now, our x value is pi on 6, so when x is pi on 6, what is cos of pi on 6? And you would all say it is root 3 on 2, which it is. So the point is pi on 6, comma, root 3 on 2. So I'll just quickly show you that in the unit circle if there's anyone still getting their heads around that at all. So here's my unit circle. At pi on 6 here, you can see that if we want the cosine value of that, the cosine value is the x-coordinate, so it's root 3 on 2. So all of these values are going to come from the unit circle. Okay. Whoops, how do I get out of that? Exit. Drop that back. Okay, so our point is root 6, comma, root 3 on 2. Now we need to know our slope. In order to work the slope out, we need to find the derivative of our function, put the same x value into the derivative, and that will tell us the slope. So the derivative of cos x, dy and dx, is going to be negative sine x. Now, if you can remember from the unit circle that was up just a second ago, the y-coordinate there was a half, wasn't it? So sine of pi on 6 is going to be a half, so negative sine on 6 is going to be negative a half. So the slope is negative 1/2. That is what the derivative is equal to at the x point. So now that we've got that, we need to use one of the methods that we've learnt as to how to work out the equation of a straight line from a point and a slope. For these...
How does it sine x equal negative a half?
Okay, so negative sine x equals negative a half. So go back to the unit circle for a second. So here's my unit circle. There's pi on 6.
Oh, okay.
And so the y-coordinate, which is sine, is a half. But we had negative sine x, so it makes it negative a half.
So it's always going to be one of those values?
For the questions that we're likely to have, it's going to be one of those questions. Yes, one of those values. Yep. And so we need to have the unit circle at our disposal in the test. Should you have it on your notes or memorised or what works for you, but you definitely need it when you have assessment on this. Okay, so back to where we were. So I'm going to use, firstly I'm just going to get myself a bit more room. I always forget to do that. It'd be nice if I could make that a default. So I'm going to use the formula that was given in the textbook as our method today. And so that means we are going to go, so when I say that formula, I'm talking about this one here. If we go back, this is the y equals f, this one here. That's one way of finding the equation of the straight line. It's as good as any. So we have the f dash of x here, x minus, and so on and so forth. So that's the one I'm going to use here. So we're going to have, let's make a line here. So we're going to have y equals f dash of a, in this case f dash of x, was minus 1/2. And we're going to times that by x minus pi on 6. And then plus, and that f dash of, so f of x is going to be at the end here, which is root 3 on 2. So what I've plugged into that formula, I've put the slope there, I've put the x coordinate here, and I've put the y coordinate there. Just filling in that formula as given in the textbook. If you're using one of the other methods, that is just fine. Now, when we expand out our brackets to get our final equation, we are going to have negative 1/2 x, which is what we'd expect, because we know that's what the slope was. And then this next bit, when we expand the brackets, 1/2 times pi on 6, a negative 1/2 times negative pi on 6 is going to be positive pi on 12. And then we've got the plus root 3 on 2 at the end. Now, that would be enough. For all intents and purposes, that would be enough to answer this question. But if we wanted to, we can combine those, the y-intercept here at the end, if we wanted to combine them, I guess we could, and we could write y equals minus 1/2 x plus, lowest common denominator would be the 12 there, so it would be pi plus 6 root 3. Just to tidy things up and have our y-intercept as a single value at the end. Okay, now what I'm going to start doing a bit more of now is, once we've done the question, I want to start visualizing them as well, okay? So let's have a look what that looks like on a graph, which I should hopefully have up already. There we go. So if we open up with our initial function, there it is. Let me just change my scale to pi. Object properties. I think it's this one here. X-axis unit is, we want it in terms of pi because it's trig. There we go. So there's our y equals cos x. If we want to know that point there, if I zoom in on it, well, I'll just plug it there. There is the point on the curve in question. I'm not quite sure why GeoGebra does this, but it actually breaks up pi in blocks of 5 rather than 6. So we just need to be aware that that's pi on 6 there. I probably would be able to change the settings somehow. I don't know how to do that, but there's pi on 6 slash root 3 on 2 right there as decimal equivalents. And if we chuck in our tangent here, so if I just go to the tangent function, which I believe is here, and I click on that, there's our tangent, which is minus 0.5x plus 1.13, 1.13 being that yucky looking fraction before us, the decimal approximation. And that's visually what it looks like. And if we wanted to put the derivative up as well, you'll see that the derivative there at the same value, if we go down here, that across there will be the value of the slope, okay? And I'll just stop the first recording now, if I can find out where it was, down there.